Problem 215, Classical Mechanics. The question is, the one-dimensional Hamiltonian of a classical particle of mass m is h is equal to p square by 2m e raised to minus x by a plus v of x, where a is a constant with appropriate dimensions. The corresponding Lagrangian is. In the present problem, we have to find out the Lagrangian. In the question, the Hamiltonian is given. We have the relation connecting the Lagrangian and Hamiltonian is L is equal to Px x dot minus h, where h is the Hamiltonian. It is given that h is equal to Px square by 2m e raised to minus x by a plus v of x. We have to find out the Lagrangian corresponding to this Hamiltonian. So let us use the equation L is equal to Px x dot minus h, where L is the Lagrangian and h is the Hamiltonian. That is L is equal to Px x dot minus h. H is already given in the question. So we can write the Lagrangian L is equal to Px x dot minus h is nothing but Px square by 2m e raised to minus x by a, Px square by 2m e raised to minus x by a plus v of x. Close the bracket. This is the expression for Lagrangian from the given Hamiltonian. But if you observe the Lagrangian, we can see that the Lagrangian contains both Px and x dot and also x. The Lagrangian contains Px. But from the Lagrangian dynamics, we know that Lagrangian is a function of x, x dot and t. That is, a Lagrangian should contain x, x dot and t, and it does not contain Px. Lagrangian should not contain Px. So in order to write the equation for Lagrangian, we have to replace the Px term in the Lagrangian with x or x dot. So how to replace this Px term with x or x dot? And for that purpose, let us use the Hamilton's equation of motion. That is nothing but x dot is equal to dou h by dou px. This is the relation connecting x dot and px. X dot is equal to dou h by dou px. We have h is equal to px square by 2m e raised to minus x by a plus v of x. Therefore, x dot is given by dou px of x dot is equal to dou px of h and if you take the derivative, you will get x dot is equal to px by m e raised to minus x by a. X dot is equal to dou h by dou px, and that is nothing but px by m e raised to minus x by a. From that equation, we can write px is equal to mx dot e raised to x by a. This is the relation connecting px and x dot. Now we have px in terms of x dot and x. Now if we substitute the value of px in the above equation for Lagrangian, then the Lagrangian will be a function of x, x dot and t. So let us denote proper equation number. For Lagrangian, it is equation number 1, and for px, it is equation number 2. Now let us substitute the value of px from equation 2 to the value of Lagrangian in equation number 1. That is, let us substitute 2 in 1. Now we have the equation for Lagrangian becomes, what is px? It is mx dot e raised to minus x by a. Already there is an x dot minus, within bracket we have px square by 2m e raised to minus x by a. We have px is equal to mx dot e raised to x by a. Now take the square divided by 2m. Let us give a square bracket there. It is better to give square bracket. So within the square bracket we have px square by 2m e raised to minus x by a. Px is equal to mx dot e raised to minus x by a. That is, the term inside the bracket becomes mx dot e raised to x by a square divided by 2m, mx dot e raised to x by a square divided by 2m. Outside we have e raised to minus x by a. It is x by a, okay. Plus v of x. Now let us close the square bracket. Let us simplify the expression for Lagrangian. Then L is equal to mx dot square e raised to x by a minus, if you take the square and divided by 2m, it will become m by 2 x dot square. Now we have e raised to 2x by a minus x by a. That is actually e raised to 2x by a into e raised to minus x by a. That will be e raised to x by a. Again we have a term v of x. That is, our Lagrangian is m by 2 x dot square e raised to x by a minus v of x. Let us simplify this expression further. We have x dot is equal to dx by dt. Therefore, the expression for Lagrangian becomes L is equal to m by 2. Instead of x dot, put dx by dt square, dx by dt square, dx by dt is x dot, dx by dt square e raised to x by a minus v of x. This is the expression for the Lagrangian corresponding to the given Hamiltonian. Therefore, from the given option, option 1 is the right option.